The next, I'm also going to transition to Rohit. He's going to be moderating for the next 4 sessions. So, Rohit, I'm going to pass the mic to you.
Thank you, Michael. Next speakers, Taras and Andrea. Right.
Preparing the headsets.
So Taras and Andrea will be speaking about SONiC Lite. Please go ahead and introduce yourself. Thanks.
So I believe you've heard that Dent is striking the SONiC. Now Empire strikes back. Let's talk how we can do SONiC on enterprise edge, or at least we can try. Today's topic is how we can fit SONiC on the small box. And without further ado, let me introduce myself and my colleague Andriy. My name is Taras Chornyi. I am from PLVision. We have Andriy Kokhan from PLVision as well. And let's jump in right to the discussion. So this is the typical SONiC platform as of now. Yes, we all know how SONiC begins. This is the hyperscale use case. Microsoft did a great job. There is a huge community around it. It's powerful enough. It's fancy enough. It does what it needs to do. It's Xeon-D based. It has a huge amount of RAM, huge amount of storage. It has a high-speed ports, and it runs SONiC quite well. If you will go to the SONiC website, you can find the hundreds of platforms supported and then images for them. If we will take a look what's happening on the management and access switch, it's a bit different area. You can go with MikroTik, which is several hundred of dollars, and it's or with Cisco or any other management access level switch. Typically, it's 1 gig switch. Typically, it's ARM, MIPS, or x86, not that far, but still, it's available. It has a really, really low in memory if you compare it to SONiC, and it has a really, really low on the NAND and storage on it. It can run SONiC. It's a question. If you will go to the SONiC, you see there are 1 gig boxes available. You can run SONiC on 1 gig boxes. You can have the feature set available, and you can basically do it. But why we are talking here? The idea is that the SONiC, the community version of SONiC, is not optimized, and it utilizes huge amount of resources that it shouldn't. And here I would like to Andriy to tell us how SONiC uses that resources.
Thank you, Taras. So before we started doing this, even we are targeting to the hardware devices. We decided that, in fact, since we want to be focused on the software, we can use SONiC virtual switch as a DOT to do our exercises. Of course, we took one of the latest available on the GitHub, built on Azure, and we provided some limited resources to this virtual machine image. It was 2 CPUs and 2 GB of RAMs. And for our measurements and experiments, we used mostly standard utilities available in the open source, like systemd, bootchart, perf, top, SMAM, and so on. But here you may ask, how about vendor-specific part? As all of you know, ASIC SDK can be also very resource hungry. It can use thousands of megabytes of disk space, and it can run multiple threads and so on. We believe that this part of optimization should also be done, but it should be done per vendor specific case. So we took this out of the stage and focused just on the SONiC specific stuff. Just to make these virtual machine images busy, we started some topology. It doesn't matter actually what topology exactly will be. Started some amount of virtual machines. And firstly, we were trying to measure SONiC state when it's idle. It means when all applications are up and running. Also, we were interested in what will happen when we try to reconfigure SONiC through configure load command, which actually regenerate a lot of stuff from the templates. And what's important as well, it's user experience. So when you SSH to the box and want to configure something, you should be confident that commands will be executed in some sufficient amount of time. So when we did the very first measurement of RAM, we realized that almost 2 GB of RAM is utilized, mostly by user space applications, some amount of that by kernel dynamic memory. And we tried to make a snapshot of what applications is doing what and how many memory they are using. And we were surprised to see that a significant amount of RAM is used by different type of Python applications that are not related to the control plane itself. For example, here you can see supervisor D, container config D manager. All of them are related to the process how we support microservices inside SONiC. So obviously that's something we should take care of. Now when it comes to CPU usage, again, we saw that the Python application as a major one that takes significant amount of CPU in different scenarios. Here we highlighted just 2 of them. As you may know, there is a SONiC config gen tool inside SONiC, which converts from Jinja templates into the configuration, and it runs multiple times during the boot process, and it uses a significant amount of CPU. And the question is whether it's efficient way to go when we want to create the configurations. Probably some of those templates should be eliminated. The second is, as I mentioned, Python application. As you know, SONiC, it's a programming language environment. You can find the C, C++, Go, but significant amount of applications written in Python. And we see that it's actually probably not that efficient approach, especially for small boxes. And finally here, we choose one of the most commonly used utility. As you know, in SONiC there are many ways how to configure SONiC, how to check the status. We just choose show interface status command, and we decided to play with it to understand what the common problems in the user interface. To experiment with this, we throttled down the CPU, and red line you can see here, that was original time of response, depends on how slow CPU is. Then we just made a small update inside Python scripts, moved Python imports from the file scope into the function scope. And we got almost 30% of improvement by simple change. Obviously, it's design gap that should be fixed in other tools as well. Then in SONiC, we have system health utilities that monitors different daemons and applications and so on. It's written in Python. We disabled it, and what we see, we got another 10 or 15% down. And we realized that, in fact, it impacts not just these utilities, but all other applications as well. We don't mean to remove system health D from the SONiC, but it's obvious the place that we should optimize to reduce the impact. And finally, green line. We decided to check this specific command, what is used inside, and we see it just call another Python application. And if we call those another application directly, we got another 10% of improvements. By this, we mean that we should inspect one by one each command and also try to make command-specific improvements to reach the final goal. Now I want to pass the word to Taras again.
Yeah. So from the CPU memory, it's the most important part because this is how you handle your runtime. Storage, it's boring one, but still important one. If you can reduce your storage footprint, you can reduce your BOM cost. Same true for the CPU and memory, but storage is also important. And we wanted to understand what is being used, what takes that much storage in SONiC. And we've separated several areas which we wanted to identify how they're utilized. This is the static lips, and for us, the thought process should not be static lips in production. You can use them for development, but maybe with some small exception, but it should not be static lips in production. Dynamic lips, it should not be unloaded dynamic lips in your runtime. If you have an unloaded dynamic lip, most likely, in some cases it might be, but most likely you have some waste of your space on the disk in that, and not loaded kernel modules. I was really surprised to realize that there is an ATI video driver built in SONiC. Maybe, I don't know, there is a Larry from EdgeCore. They are doing the box for SONiC with the monitor and ATI graphics card, but I doubt about that. So each area has to be removed as well. We did a test on the latest VS image, and we've realized that the total size of static lips is about 400 megabytes. The total size of dynamic unloaded lips is about 600 megabytes. The total size of dev packages, which is much, much better. If you would remember, last year, the Marvel was doing the hackathon, how they shrink the size of the SONiC by removing dev packages and some other stuff. It was much worse then. Nowadays, SONiC did it already, so there's almost no dev packages available. But still, there are almost 300 megabytes of unloaded kernel modules. At this, when you have the total used space, right after you install the SONiC, 2.6 gigabyte. So we see a huge part of this space can be freed. So we've freed it. We did it as the several attempts, and we were removing the pieces that are definitely necessary. For some use cases, we want to give some pieces back. For example, on the previous slide, there is a 300 megabyte of unused kernel modules, but we removed only 62 megabyte of them, and because of the net filter modules, which are being loaded when you are installing the root to the kernel. There is autoload, and there is also some PHY drivers specific for the management port used on some boxes, which we didn't touch. But if you want to tile down the specific and squeeze the SONiC to specific box, this is also the area for improve. This is the generic one, and by doing this, we've saved around 12% of the disk, about 300 megabytes. And we went further. So we started to think about, okay, SONiC in the data center use case, great. You have FRR, you have BGP, you have iBGP, you have ISIS, you have OSPF, MCLock, SFlow, and other really, really interesting features. For the management and access, you don't need them. So we've realized, let's define the flavor of SONiC. Something that you can choose. I want this SONiC for the layer 2 switch, for example, and remove these containers from the build. Not remove them, but just disable. It's still the SONiC, still the same build system, just that those containers are not built for that specific image. By doing that, we got 45% of the original size of the image. And we went a bit further, because at this moment, there is no way to disable FRR. It's cooked to the SONiC. It says it's microservice. It is, but with some asterisks. By changing the build system a bit and disabling the FRR and keeping the only static routing in the SONiC, we've saved 5% more of this. So as the summary, what we've identified and what we've fixed, here we just highlighted, what we can highlight as of now until we will be more vocal about it. Is for the RAM usage, there are a lot of config generation and wrappers on top of the Docker and the Docker supervisor that takes up to 30% of the RAM. This has to be eliminated and changed. From the CPU utilization, it's more or less okay in the steady environment, unless on the configure load, when we are going back to the previous statement that I made, it's the config generation, it's the Python loading and importing stuff, which spikes utilization and get back. From the storage, I would say it's more or less okay. Some cleanup has to be done, and we will be doing this back to the community, and I believe this will be even well accepted by the community, because it's definitely something that shouldn't be in the SONiC by default. And what we definitely want to get back with and to talk with the community, engage with community on, is let's start define the different flavor of the SONiC for different use case. We know that hyperscale happened. We know that DC happened. Let's move it further. Let's move it for the access, management, enterprise networks. As the call to action, we are doing this. We are optimizing SONiC CLI scripts, and I'm pleased to announce that the company I'm working with, PLVision, is joining the SONiC as the project, and we will be contributing our things back to the community while we are progressing with this. Additionally, we would recommend to extend the CI/CD process, at least for the Python stuff, that can show you that you've added this much files. This will give you the plus 4 megabytes, plus 1 megabyte. And we want to encourage the community to do the profiling during CI/CD, at least maybe once a month or once a release, to understand, are we still okay on the optimizing the, are we still optimal here? And my time is up here. Maybe
thank you.
Some questions? Or
yeah, thank you so much. I think we kind of late on time, so we can maybe take the questions offline, if you don't mind. Thank you so much for this.
Thank you.
Big round of applause for Thank you.